Hi, I'm Tim Tyler, and this is a video about betting on binary sequences, sequence prediction in general, and the significance of the idea in the context of machine intelligence. A component capable of predicting the future seems likely to be a major element of most machine intelligence projects. If you know anything about machine intelligence, you'll probably have some basic understanding of how chess and Go programs work. They consider the future consequences of their possible moves and then select the one that they think is most likely to lead to the best outcome for them. If you break such systems down into modular elements, one component tries to predict the likely future consequences of its actions, and then another component assigns value to the results of those actions. Because the future is uncertain, the predictions consist of a branching tree of ever-dividing possibilities. Because the tree rapidly becomes large and unmanageable, other algorithms attempt to prune the tree to quickly eliminate those branches that apparently deserve little consideration. Sequence prediction is concerned with the problem of calculating the tree of possible future situations in the first place. It's a model of serial prediction, and parallel prediction seems likely to follow from a solution to the problem of how to build a serial predictor. In many respects, prediction is a central core problem for those interested in synthesizing intelligent agents. If we could predict the future, it would help us to solve many of our problems. Also, the problem has nothing to do with values. It's simply an abstract math problem that can be relatively simply stated. The problem is closely related to the one of building a good quality universal compression algorithm. For real sequences, prediction should be probabilistic, so if we imagine a prediction of a binary sequence, rather than making a prediction of 0 or 1, the prediction should be in the form of the probabilities of those events. Sequence prediction can be dealt with as a reinforcement learning problem. So to illustrate that, I've got a box here with a reinforcement learning agent trapped inside of it, and this tape that's going into the box and coming out the other side is designed to represent the agent's sensory stream. And you can see here I've got a little sensor, and that senses whatever digit is on the tape here. So the agent's sensory information comes in, and the next digit that it sees is a number 1, and then it updates its model of the world inside the box, and then it makes another prediction about what the next digit is going to be, and then it looks at it and it's a 1, and basically the agent makes a prediction about what symbol it's going to receive next, and then it observes the symbol that's actually delivered, and it uses a kind of betting system that describes the rewards associated with the prediction that it's made, and that can be used to drive a kind of reinforcement learning algorithm. And the way the prediction system works is that it acts like a bookie, so it sets the probabilities at the chances that it thinks it will observe 0 or 1 under the constraint that those probabilities have got to add up to 1, and then you've got to imagine that punters bet on the available options. So for the sake of this discussion, we'll imagine that a single punter is always forced to bet £1 on each of the options, which in this case are 0 or 1. So here a punter will put £1 on 1 and £1 on 0. The bookie will make its prediction, set the odds, and then the digit that comes out is revealed, and then the bets get paid off. And the bookie's aim is to try and make money from the punter, basically, and the punter's payoff is the reciprocal of the probability in pounds, and that's the payout that they get at the end of each session. So if we imagine the bookie sets the odds at 90% chance of 0 and a 10% chance of 1, then if a 0 is observed, then the punter collects £1 and 11 pence, which is the reciprocal of 0.9, which was the probability the bookie set. Whereas if a 1 shows up on the tape, then the punter gets to make £10, which is the reciprocal of 0.1, which was the probability of that. So if we see what actually happens, it's a 1. So the punter gets £10 in that case. So here the reinforcement agent is quite severely out of pocket. It's made a bad prediction, it's getting punished for it. So such a scheme has got the effect of rewarding the bookie for setting the correct odds and punishing him when he sets long odds for a result that's actually observed. The training data that's used in the stream can come from practically any problem, passively predicting video streams, audio streams, text, web pages, whatever input stream you fancy really. And then what you need is a reinforcement learning algorithm or some other kind of learning algorithm to go inside the box. And of course that's where the problem lies. Such algorithms are not known in the general case, and it seems like a much simpler problem than going straight for an intelligent agent though. So you don't have to do any messing pre-pruning of the kind of tree of probabilities. You just calculate the next symbol, and that if you apply it iteratively, it gives you the whole tree. But you don't have to do any tree pruning. You don't have to figure out what's valuable and what's not. The there's a constant bet which is made at each stage, so each symbol is considered to be equally valuable, and then the testing cycle for this type of system could potentially be pretty rapid if the training data can be supplied quickly enough. And there's many applications for a prediction engine with the financial payoffs, so predicting stock market prices, predicting the weather, or anything else that people are allowed to bet on, basically. And optimization strategies could be used to try and solve the sequence prediction problem, perhaps using a large population of bookies and punters in resource competition with each other. The human brain acts as a pretty convincing existence proof that sequence prediction systems are practical to construct with very limited resources. Plus, we have the results relating to universal artificial intelligence that strongly suggest that a predictor can quickly learn to do astonishingly well in the real world if the only thing that it knows about the world is that it exhibits the regularities exhibited by Occam's razor. Since the problem of sequence prediction seems so much easier than building a whole machine intelligence, it seems likely that it will be solved first. The human brain has already had its memory capabilities eclipsed by those of machines. Its arithmetic unit is also made pretty much totally obsolete by machines. Predicting the future seems like to be one of the next faculties of the human brain to be eclipsed by machines. This is a pretty big and important function of the brain, and a solution to the sequence prediction problem seems like to have very far-reaching consequences. Enjoy!